Yes, sir.
Okay, you remember we were calculating the amount of charges for the charges on sphere Y and X, and to verify, or Ronewa, can you use your calculator and see if we're gonna get the right answer? I just want to verify.
So am I verifying the -5 times?
Yeah, because that's what we had in the question.
Okay. Can I see the sum again?
Okay, let me accept Mamuswane first. Okay, I think it's in. Because if you check in the question, you will see that you see 2.3. It says if the force between them is 5 times 10 to the power of -4. So I want to see if what we got will give us 5 times 10 to the power of -4. Because our solutions were 1.5 times 10 to the power of -8 and 3.7 times 10 to the power of -8. Let's see if we will be able to go back to the verify what is in the question. How much did you get? How much did you get?
Sir, I'm getting a completely different answer.
Which is how much?
Negative 0.004995.
Okay, let me see. You said you are getting 0.0004
49995.
Okay, 499. Okay, if we are writing it in scientific terms, it will be what?
Negative 5 negative 4.
It will be 4.
So the answer is negative. It's negative 0.00049995.
Okay, so
Yes.
if we are writing it in scientific terms, what will it be?
Maybe negative 4 times 10 to the power. Is it
10 to the power
3? No, 4.
-4.
-4.
And on our equation, it says the force between them is 5.
Yeah.
Isn't this 5?
Yes, it is.
Okay, meaning we have successfully verified. Haven't we?
Yes, sir.
Okay, it's just that I don't wanna go back and verify the electric field. You can do that. You can do that separately for yourself. I'm sure you will find the same answer that you have in the question, which is 8 times 10 to the power of 4. Okay, but I've realized that it was one of the difficult questions, I think. 2.4, however, I think it was doable. What is the resultant force, Kathis? What is the resultant force?
Okay, a resultant force. It is a single force. It is a single force having the same effect as all other forces acting together.
That is true. That is true. Okay, so now they're saying draw a free body diagram of all forces acting on the planets. Okay. The first, let me see, it will be, let me plug the mouse. Okay. Okay, during a Big Bang, two charged planets, planet A with a mass of 6 times 10 to the power of 4, and another one with 8 times 10 to the power of 23. And the two charges respectively were located at a space of 3.8 times 10 to the power of 5 kilometers. Okay. The free body diagrams 2.4, 2.4.1. The resultant force is a single force representing some forces. Okay, 2.4.2. Free body diagrams will be as follows. Planet A and planet B. The first force that we will have is the force of attraction due to gravity. I will call it F G. We will also have another attraction since the two planets have two different, they have unlike charges on them. Unlike charges attract each other. A positive and a negative will always attract each other. So this will be force electric. The same thing with B. We'll have Fg, the force of gravity, and also F electric. Those are the free body diagrams. And now, the question that follows, it says, calculate the net force between the two planets. Okay, Romeo, this force right here, if you are comparing FG on this free body diagram and FG on this free body diagram, how do you compare them? Are they the same or are they different?
I would assume they're the same.
Why? What is the reason? Kathy, so what is the reason? Why are they the same? Mamson, why are they the same? I know you have an answer. Why are they the same?
Um. Is it not because I don't know?
But you have said the answer last time. Oh, Romeo.
So I don't sound like I have the right answer, but I'm saying, so does it have anything to do with Newton's law of universal gravitation?
It has to do with Newton's law.
Okay. So would it be the same? Because the
I know Mamson knows the answer. She has said it before.
So why do I not remember saying this answer?
You have said it before in the previous question.
Is it because they both feel the same force of gravity from the Earth? I don't know.
There's a Newton third.
Oh, okay. Newton's third law.
Newton third law.
Oh yes, the action reaction pair.
Do you agree?
So yeah, I agree.
Okay. Yes. So either way, I can use either of the two. Even your electrical, your force electric, it will be the same. You agree?
So
You agree? Yeah.
yes.
If I calculate the forces on this one, I'm done. I don't have to calculate forces on this one because of Newton's third law. Okay. Let's resolve our forces in the x direction. So what is it that I'm gonna have, Mamswani? If I'm using this one.
You are gonna have, well, depending on your direction, you're gonna have. Yeah, you need to have your direction first.
Okay.
So you're gonna have F electric only on A, sir.
Hmm?
We're talking about, okay, F electric minus F electric on B
Minus.
the electric force on B.
Okay. Here we go again. I said Newton's third law. So you don't have to resolve what is happening here. So we only consider the forces that are acting on one free body diagram at a time. These are two separate scenarios, and there's no need for us to solve the two. Because even if you subtract, you're gonna get zero most. Do you want a zero?
No, sir.
Okay. So I gave you guys this question because I know it was going to be tricky. I wanted you guys to understand the Newton's third law in details. So forget about B. Choose one. If you are using A, let's use A. If you are using B, let's use B to give you the same answer. Okay, let's consider A.
So, but there's no other force acting on A apart from Fg, and you said that the force of gravity is the same on both, on both objects.
Yes, so we only consider one object at a time.
So is it going to be plus Fg then?
Yes.
Because it's also, okay.
And then?
Is equals to MA.
Correct. The thing is, even if you use object B, you are gonna get the same thing. It's just that you're gonna get the same thing. If you choose that direction as positive, you're gonna get the same equation. You agree? Okay. Now F electric will be Mamsani.
So?
F electric, it will be
F electric will be KQ1 times Q2 over R squared.
then plus
As Fg, which is going to be your mass times gravitational acceleration.
okay. Okay.
So why are you laughing? Am I wrong?
You are not wrong. It is just that some of the value you won't get them. For instance, we do have the mass, but do you have the gravitational acceleration? But if you have it, then I don't mind. You're not right. You're not wrong. We will get to the same answer. Okay, so if we're replacing K, it is just that if it was me, I was gonna use, if it was me, over R squared. But even if you use this one, it's okay if you can calculate the gravitational acceleration, which is okay. I will show you why. Ne? Let me show you why. Even if you use what you have given me, you'll get the same. Plus, I will write M. Do you agree? What is the formula of G, of gravitational acceleration? Mamshan.
So please repeat your question.
The formula of G, or gravitational acceleration.
G is equals to gravitational constant M over R squared.
G over R squared.
No. What? Over what? Yeah, sir, it's not over R.
It is over R squared. I agree, but you said G over R squared.
Oh.
What is the right formula? It is GM. Do you agree with this one?
Yes.
Is equals to MA. But if I rearrange this formula, am I not getting this?
Sir, you are.
Okay. So no problem. I'll just write it properly, the way you were supposed to write it. Plus GM1 M2 all over R squared. is equals to mass times acceleration. Okay. From here, K will give us 9 times 10 to the power of 9 times Q1 is 5 times 10 to the power of 15 times minus 3.45 to the power of 14 divided by okay, so what will be my R? What will be my value of R? Ronel, if we go up, what will be the value of my R, the distance between the two planets? It will be
So would it be 38?
it will be okay, let's write it down. It will be
Would it be is it 38,000? Oh, am I supposed to put it in meters?
what will it be? Do you have the question paper with you?
Sorry, let me just open it.
Okay.
So the question paper says
Are we allowed to like write 2 on that weird thingy here?
so which question are we doing? Oh, it says there
Yeah.
The value of R.
30. Yeah, it says there 38,000 kilometers away from each other.
But remember, I have to write it in meters. So how many zeros?
Yes, so that's gonna be
6 zeros.
yes.
Okay. And then is it done?
Great.
Is it done?
No, sir. Yeah, so that's what I'm getting actually.
Let me check. It says oh, you said, oh, that's about it. Unfortunately, it is not, because the distance between the two planets is this one. Ne? But the distance between their centers, you have to add both their radiuses.
Oh,
You agree?
yes, sir.
Yes. We have to add their radiuses as well in order to find the value of R. So this is 3.8. Then the other one, I think it was 0. 0.7 or 700 kilometers. So 700 will be 700. Then I will add 1, 2, 3 zeros. Then plus, what is the radius of the other planet? Six four zero zero 6400. Then I will add 3 zeros because I'm converting kilometers to meters. I need to add 3 zeros.
Yes, sir.
And then this is squared. Okay, then plus the value of this is our planet. Okay, 6. Okay, the value of G, it is 6.67, right? 6.67 times 10 to the power of, is it minus 11? Times, what is the mass of the other planet? It was 6 times 10 to the power of 24 kgs times 8 times 10 to the power of 23. All over the same distance, because it is the distance between the centers. So we have 33800 1, 2, 3 plus 700 1, 2, 3 plus 6400 1, 2, 3 squared. So if we're using the calculator, what do we get there on top? So all this is equals to MA or net force net, either way. Okay, so what do we get? I got 7.633 times 10 to the power of 24 plus the other one gave me 1.574 times 10 to the power of 34 is equals to F net, which is equals to MA. And the answer is force net is equals to 1.57. If you're adding the two, how much did you get? I got 1.574 times 10 to the power of 34. What is the unit of force net, Romnel?
That is it not Newtons?
Yes, okay. 2.4.
So
Yes.
how come you got 1.574 times 10 to the power 34? So I got 10 to the power 23.
10 to you got 1.5 times
10 to the power 23, not 34.
23. But the first one was correct, right?
So I put in all of that, all of those calculations in ones. I didn't do sections.
Is it? Damn. Okay. Can you try to do them because I got a different answer. Mom, Sam, did you get the same answer?
Okay, so maybe I should just try again.
Okay. 6, 7 times 10 to the power of 11 of 11 of minus 11. Sorry.
So I got 1.574 times 10 to the power 34.
Okay.
The first question. Oh, so maybe it's just me. But I'm definitely not sure about. I think it's incorrect because of the way I calculated it.
Oh yes, because I got a different answer. I got 10 to the power of 34. Mom, son, did you get the same value of 1.574?
Yes, sir.
Okay, and the first one you got the same.
Yes, I got the same for the first one.
Oh,
Okay.
so I got it now. I got it.
Oh, okay. And the answer that I got was 1.574 times 10 to the power of 34. That is the resultant force. Now, what is the direction of the force, Mamsai? If you are considering A. It will be to the right, because I was considering A, but if you are considering B, it will be to the left. So your object will accelerate to the left because there is a net force, Newton's second law. Okay, 2.4. 2.4.4, it says, calculate the net electric field halfway between the planets. So, Ronewa, what will be the formula of calculating the net force halfway between the planets? So not the net force, the net electric field halfway between the planets.
The
This is the picture she sent.
would it be F is equals to K?
It will be Mamswani. What will be the formula for calculating the net electric? Let me check. 2.4.4. Calculating the net electric field halfway between the planets. The net or the resultant electric field. What will be the formula? Mamswa. We have two planets, planet A and planet B. They both have a charge. If you put a test charge there in the middle, that net charge will experience an electric field produced by A. It will also experience an electric field produced by B. So the electric field net is equal to the electric field produced by A plus the electric field produced by B. If there was another planet here, we were gonna, planet C for instance, we were gonna add planet C also. It will contribute to the electric field. It will produce an electric field, and that electric field will be felt by a point charge or by a point test charge that you put in between the planets. But anyways, let me remove C. So what is the electric field produced by A, Mamswan? The formula of the electric field produced by A. Rodney, what do you agree?
Yes, sir.
And then the one for B. So you will get your mark for writing the formula. Then this will be 9 times 10 to the power of 9. And QA is given by 5 times 10 to the power of 15. All divided by what will be the distance R? Mam Swan, which is halfway. It will be the same as the previous 1, 2, 3 plus 6, 4, 1, 2, 1, 2, 3. However, because it's halfway, we will divide it by 2. 10 squared plus 9 times 10 to the power of 9 times 3.45 times 10 to the power of 14 divided by, again, the distance will be the same. 1, 2, 3 plus 700. 1, 2, 3 plus, you can be calculating the first expression, this one. Then plus 6400, 1, 2, 3. All over 2. All of them divided by 2. Okay. So how much are you guys getting? Because I got 6.106 times 10 to the power of 9. And the units is newtons per coulomb. That's the unit for electric field. You will get a different answer. You'll get a different answer.
No, sir, I got the same answer.
Okay, perfect. Now I just want to ask Roneo, why do you think I have added the two electric field, and also in the process of adding the two electric field, I disregarded the signs of the charges. The other one was negative, if I'm not mistaken. Let me check. Why do you think I disregarded it when I was calculating the net electric field?
So you were saying one charge was positive, one was negative.
This one.
Yes,
So it should
but
say for repeat question 1 for a 24
I
hour
wrote 3.45
digital clock.
with a positive
So
sign,
if
not a
anything,
negative.
if I get that question wrong, then this one might as well also be wrong.
So would
So
the
if you-
signs not cancel out?
Okay.
The sign is not.
I started with it, but it is there.
So would they not cancel out, seeing as one is positive, one is
Yeah.
negative?
Yes, I think you are getting there. It's just that the way you analyze your electric field is that you put a positive test charge, and then our sign was +5, and the other one was -3.445, right? Okay, you put a test charge. What will happen to that test charge? If you choose the positive direction as the direction to the right, your positive charge, the contribution of your electric field due to A, it will push your electric field to that direction. You agree?
Yes, sir.
Okay, and then what will happen if we disregard A? What will be the interaction between B and our test charge? Where is the test charge going to move due to B?
When you subtract,
So would it not move to the left?
It's 2 years old.
It will move to the left,
Yeah.
this direction.
If A is going to the right, so does B not go to the left?
No, that's not how you analyze your electric field. The way you analyze your electric field is that you put a test charge where you are analyzing your electric field. Your test charge is a charge, and you watch what happened to that charge.
4, 5, 4, 6, 8, 12, 16.
So,
and that's where I ended. Oh,
this charge will be pushed by A to the right. I agree with you, right?
Yes.
Now let me disregard A and consider what happens to my test charge if I have charge B. What will be the interaction? What will happen to our test charge? Where will it move due to B?
To the right.
Mamswan, do you agree? Do you agree that it will move to the right? Mamswan? You are right. It will move to the right. So we have two contributions of electric fields. The The reason why we added the two is because they are both going to the same direction. The other one is pushing your Q, the other one is pulling it. Because it has a negative sign, negative and positive, they will attract each other, so it will move into the right. So that's why I disregarded the sign and I just added the two electric field. So if B was positive, unfortunately, this sign was going to be a minus because your electric field or your positive test charge was going to be repelled. It was going to go towards the left. Therefore, without doubt, I was going to put a minus there. Are we all in the same page?
Yes, sir.
Okay. Let's go to the next question, or do we have a question? And do you understand why I divided by 2, Ronel?
Yes, sir.
Okay, perfect. Now let us go to a.
So
Okay.
can you hear me now?
Yes, now I can hear you. Do you understand? Did you understand why we had a plus sign instead of a minus?
Sir, I actually have a question.
Yes.
So isn't our test charge positive?
It is always positive, yes.
But then if B is negative, why is it not moving to the left instead of the right? I mean, why is it not moving to the left instead of the right?
Or to the left. Okay. Okay. Are you attracted to male or female?
Yeah.
Female. Sorry to ask that. Is it female?
No, it's male.
Yeah.
It's male.
Yes.
Okay. So what do you think will happen? A plus and a minus. Are they gonna be attracted or are they gonna repel each other?
They're gonna attract.
Okay. So when they attract, what will happen to Q? Where is it going to move?
It's gonna move. Oh, it's gonna move to the. Okay, I get what you're saying now.
You agree?
Yes, I agree.
So we will have two. We will have two contributions, and your Q will go to the right on both contributions. Do you agree?
Okay, sir, I get you now.
Yes. So if B was positive, then your Q was gonna go to the left, and we were gonna have a minus.
Yes, sir.
Okay, perfect. Let's go to the next one. The next one says, calculate the gravitational field strength experienced by planet B due to planet A. Gravitational field strength or the value of G, or gravity G. How do we calculate the value of gravity? What is the formula, Ronel? The formula of calculating the value of G. A gravitational strength. Mamsan, do you know the formula of calculating the value of G?
Sir, is it not GM over R squared?
Mm-hmm. Okay. Okay, so the value of G will be, let's see. So we said the gravitational field of experienced by B due to planet A. So which planet is producing the field?
Is not planet. Which
planet is
planet?
producing the field?
Planet A.
That's correct. Therefore, the M of the host is the M for planet A. Okay.
Yes.
No problem. So this will be, let's see. This will be, we will have G equals 6.67 times 10 to the power of minus 11 times the mass was 6.4 times 10 to the power of 23 kilograms divided by, what is the value of R? What will be the value of R? What will be the value of R? Manswat. It will be the same. So we are going to have what was the value of what will be the value? Gonna be 38 plus 700. It's gonna be the same. It's gonna be the same distance. So it is 3800 plus 700 plus 6400 So how much do we get? Divided by, let's see, 800 123 plus 700 123 plus 64 122 Did you all get the same answer?
Yes, sir.
Okay, perfect. What is the unit of G? I'm sorry. What is the unit of G?
Meters per second squared.
It is
Meters per second squared.
Newton per second squared. Rhonda, what do you agree? It is Newton per mass. I agree. I agree with that. Or meters per second square. This is acceleration, gravitational acceleration. Mamsan, do you agree?
Yes.
And do you also agree with Newton per meter?
Sir, do I agree?
I don't
Yeah.
think you do.
No, I don't agree.
Okay, Newton's second law says force equals ma and acceleration equals F over m. Do you agree?
Yes.
What is the units of F
N.
and the units? Actually, you're right. Yeah, you're right. I don't know what came to my mind, but do you agree with that one?
Yeah. That makes more sense.
Yes. So this will be Newton per kg. Yes. Okay. The second question says, the next question says, will the planets mesh after contact between the planets or bounce back as soon as the two planets come into contact? Show your calculations. Okay. Okay. So when the two planets come into contact, what will be the radius between them? Let me draw a sketch. So this will be 2.2.6. What will be the value of R, Mam Swan, when they are now in contact?
So will it not be the radius of A plus the radius of B?
Yes. Which is going to give us how much? It will be 6400 000 plus 700 000. So this will be, if you use your calculator, you're gonna get 7100000. Unless if you're getting a different answer. Meters.
No, sir.
Okay. Now, after contact, Roneo, what will be the new charge? What will be the new charge of the spheres after contact?
Oh no, I was just thinking because it said the days to the same day in the week after record multiples of 7 the number.
Roneo?
Also explain why I shouldn't 31st.
It will be Mamsan, what will be the charge or the new charge of sphere A and B?
So will it not be a negative charge?
Q new
Or is it
equals
equals
to
to Q?
divided by 2. After contact, you remember from electrostatics, most after the two spheres are in contact, when you separate the two,
Yes.
you agree?
Yes, sir.
Okay, so after contact, we will have 5. Rhonda, what do you agree? Plus 8 is a minus 3,45 times 10 to the power of 14 over 2. So I got 2.328 times 10 to the power of 15. So each sphere will have that amount of charge after collision or after the contact. So now I want to draw a new free body diagram, because after a small separation, if we're assuming that just after the collision there'll be a small separation, each sphere will have that amount of charge. Now, the new free body diagram will be different from the first one. So, sphere A, what will be the direction of your force of gravity? Mamswa,
So please repeat your question.
what will be the direction of your force of gravity on planet A?
Not be to the right.
Yes, it will still be to the right. And then the direction of the electric, the force electric,
It's not also to the right.
remember the new charge, each sphere will now have positive 2.328 times 10 to the power of 50. That's the new charge for each sphere, for both spheres.
Oh, so will it not be to the left because it's repelling from A? From B?
Yes. So in electrostatics, usually after contact, the two spheres will usually repel each other because they will contain the same charge. So repelling will mean it will be going the opposite direction. So it is the same thing with B. Fg and F electric. Okay, now to see if the two planets will smash or not, if F electric is greater than Fg, it means the resultant will go to the left. You agree? If F electric is greater than Fg, it means the resultant will point to the left. Do you agree, Mamswan?
Yes, sir.
So that's what we want to prove. So let's resolve in the x direction. So what are we gonna get?
So it's gonna be Fg minus F electric.
Equals to
MA.
MA or F net.
Yes.
Okay. So Fg will give us, it will be, what are we looking at? We are looking at what we will get out of Fg, the formulas. Mamswan, what is the formula for Fg?
Is it not mass times gravitational acceleration?
You can say so, but at the end of the day, it will come to this guy.
Oh, and you said this before.
Yes. It's better to just go straight. So we'll take it as. So when you're dealing with inverse square problems, it's better to go straight to this one.
Sorry.
Okay. F electric again. A Q1, Q2 all over R squared equals to F net. Okay. Now we're gonna have 6.67 times 10 to the power of minus 11 times the other mass is 8 times 10 to the power of 23 times 6 times 10 to the power of 24 divided by 7,100,000 square minus K is 9 times 10 to the power of 9 times Q1 is, what is Q1 and Q2? Ronel. Q1 will be what will be the value of Q1? Mamsan, what will be the value of Q1?
So will it not be positive 2.328 times 10 to the power 15?
Yes. It will be positive 2.328 times 10 to the power of 15 times what?
Times 2.328 times 10 to the power 15.
Yes. Okay. Divided by the same radius. 1, 2, 3. Okay. So it's all is equals to F net. Okay, so how much are we getting? How much do you get out of this? You can start with the first expression. This one.
So I'm getting 6.35 times 10 to the power 24.
Yes.
35.
Then minus the second one will be
So for the second one, I got 9.676
9.676 times
times
10 to the power of 26. Which one is bigger? This one or this one?
Which one is bigger?
Yeah.
I think it's the first one. Is the first one not bigger?
The first one is bigger.
Yeah,
Because
yeah. Alright, so it's bigger because is 9.676 times 10 to the power 26 not negative?
okay. This one was only gonna be smaller if you were talking about a negative exponent. There I would agree with you. So if you disregard the minus sign, if you are just comparing the two expressions, which expression is bigger?
Second one, if I disregard the negative sign.
It is going to be
The second one, 9 times 676.
yes, which is F electric.
Yes.
Okay. So if we go back to our diagram, do you see that? Do you agree that the net force will be going in that direction? Okay, but let's find the F net, then we'll see. What will be the F net?
The F net will be negative 9.612 times 10 to the power of 26.
Negative 612 times 10 to the power of 26. The units is newtons. Okay, our F net is a negative number. Okay, what was our initial direction? That was positive.
Right was positive. To the right was positive.
So if we got a negative answer, where does our net force point?
So our net force points to the left.
To the left. That's perfect. Now, if it's pointing to the left, will the two planets mesh?
No, they will not smash.
No, they won't, because this one will also point to the right.
Yes.
Therefore, the two planets won't mesh. Okay. Yes, so I think I will do question number 3 on the next lesson. Question number 3 on the next lesson. So I think we did a lot today. Do you guys have any question?
No, sir.
Rondewa, do you have any question?
No, sir.
Okay. Just a quick recap. What is, I just want to do rapid fire questions quickly before you leave. Rondewa, what is the formula of calculating the value of G, or the gravitational acceleration? Around an object or around a planet?
Is it GM over R squared?
Yes. Mamsan, what is the formula of calculating the electric field between two charges?
The formula for calculating
The
electric
electric
field.
field, yes.
So it's not EKQ over R squared. Electric field, yeah.
It's E equals
KQ.
Yes. Yes, perfect. Perfect. And if you have two planets, what is the value of R? Ronel.
Wait, so what was your question?
What is the value of R? If the two planets have specific masses, what would be the value of R? So this is what we are looking for. What is the value of R in this case? If the radius of the first planet is Y and the radius of the second planet is Z, what will be the value of R?
So would it not be Y plus X plus Z?
Yes. Okay. Mamswan, do like charges attract or repel each other?
Like charges,
Yes.
they repel.
Okay, perfect. And what is what can I say? Okay, if you have a planet and an object, a small object, if the radius of the planet is y and the distance between the object is z, what is the value of r, Mamswan?
The radius of the planet is y,
Yeah,
and the distance between the planet and the object is z.
yes.
It's not going to be y plus z.
Yes. Okay, because if you are dealing with a tiny object, there's no need for you to determine the radius of a tiny object because it's too small. It won't contribute anything. For instance, if they start talking about a satellite, whenever they start talking about a satellite, you don't have to consider the radius of the satellite. Okay, or a radius of a ball, it won't do anything. What else did I wanted to ask? So, Mamswan, how do we determine the direction of the electric field? How do we determine the direction of the electric field? What do we do?
So I think to determine the direction of the electric field, do we not consider the sign of the the force of the electrical force?
Ronewa? If you want to determine the direction of the electric field, what do we do? Okay, do you remember this, Mamswan?
Yes.
You put a positive test charge and see how it will interact with your charge. Let's say if your charge is -5, your positive charges will point towards your sphere. So this will be the direction of your electric field. Your positive test charge will go towards the left. Do you agree?
Yes, sir.
Let me delete this one because I don't want to confuse you. That's how you determine the direction of the electric field. And also, a test charge is a charge, nonetheless. And what did I say about, let's say if you have an interaction between three charges, 1, 2, and 3. What did I say about calculating the net force on object 1, which has a specific charge? How do we calculate the net force? What is it that we consider?
So we consider, for instance, we are going to separate the two. So you're going to consider the force of 2 on 1 first.
Yes.
and then you'll later then do the force of 3 on 1.
That's true. And then at the end, we determine the resultant. In this case, if this is negative and this is, let's say, positive, and let's say this is positive, say negative, choose between the two. A and B. Which one represents the direction of the resultant force, A or B? One now. Mamsan.
So I think it's A.
It is A, because the first one will it will move to the right, and also it will be attracted downwards. Therefore, the resultant will be there. And then, what is the formula of calculating the resultant if we have this case? Mamsan.
So
Yes.
if we know the force between 1 and 3 and the force between 1 and 2,
Yeah.
we can then use Pythagoras, or if we're given an angle, we can use, let me see.
That's
we can
correct.
use, yeah.
No one will, oh yeah. Sometimes they will give you an angle, yes. But usually you are supposed to be the one to calculate the angle. You get your resultant force, because if you get your resultant force, you will have a value, you will have a value, you will also have a value. You will be able to determine that angle if you have 3 values. Okay.
Yes, sir.
Yes. So I think that's about it. We'll see you guys next week, Tuesday. Then we'll finish question 3. Then from there, we are going back to multiple choices. Then after multiple choice, I will set up as a nice small test that is going to be timed. And on that test, you're going to write it whenever you feel ready, at any time. Okay.
So is the test nice, or is it gonna be tricky?
It is going to be average. I'm going to make sure that it matches the standard of your exam. It matches the standard of your test, but it will make you think about the basics a lot.
Okay, sir.
Yes. So I will see you guys next week, Tuesday. We'll be doing question 3. Today is the 27th. Yeah, we are still on time by far. We are still on time by far. So I'll see you guys next week, Tuesday. Okay.
Bye.
Cheers. Bye.